Well, navigation has changed a lot over the years, especially with the invention of computers. So these computers help us work out the bearings and trigonometry, and they are used in our planes and our ships of today. When you were in primary school, you would have used the compass rose, and that would you would have learnt about the north, south, east and west, and possibly the points in between, halfway between the north-east, so halfway between north and east, south-east, and so on as you go around. So that's our starting point of our bearings. In high school, the compasses that we have access to look like this. So they put in all of our degree measurements all the way around to 360, starting at north. And they've got a few bits and pieces that go with them. So we have the magnetic needle, which is always pointing towards true north. And we've got this, what we call our rotating dial, which we spin around. And here is where we actually read our bearing. There's different scales on here in case you want to use them on maps, depending on the scale of the map, or just the rule that you can use measuring on the map. Now, bearings are a measurement of an angle, and they're describing how to get from one point to another. So if you've got a bearing of point B from A is at the centre of your compass rose, and you're standing there and you're looking towards B. It tells you what direction you have to go on. Can you pause and write those notes, please? There's two main ways that we write our bearings in high school, and one is our true bearing. Our true bearing always has 3 figures and is always measured from north. So we start from all the zeros, the 3 zeros, and we measure all the way around until we get back to 360 degrees. So there's always 3 digits in your true bearing measurement. Can you pause the clip and please write that? The second way of writing our bearings is our compass bearings, and this gives us a measure from the north or south, and then we have to say if we're heading east or west and how many degrees. Those degrees are always in a measurement between 0 and 90 degrees. So if we look at this question here, this one actually, to work out the bearing of x from O, what we're doing is we need, because we're in the southern half of our compass rose, we are going from the south and we're heading towards the east. So I know it's going to be a south and an east. Now to work out the amount of degrees, because I know that that's a right angle, I get my 90 degrees, I take away my 20, and this angle here is 70. So that's why I'm in the southern half, and I'm heading 70 degrees towards the east. So it's like I'm standing at this point, I face south first, and I turn my direction of sight out 70 degrees towards the east, and then I'll be looking out towards the X. Can you write down that example, please? So here are some examples of writing true and compass bearings. So in our first example, you can see we've got this 60-degree angle measured here. So if we were writing that as a compass bearing, we would write from the north, we would head 60 degrees towards the east. As our true bearing, we have our 3 digits. So because it's only 60 degrees towards from the north, around like towards that point, I put a 0 in front. So these angles can have degrees and minutes, or just degrees. So in the second example, if I'm doing my true bearing, I stand here, always stand at the center, I face north, and then I turn my sight around and look out towards my other point, and so I've turned an angle of 245 degrees and 0.9 seconds. So when I say you've got to have the 3 digits, it's the 3 digits for the degrees. You can also have minutes. In the compass bearing, this is in the southern half, so from the south you're turning the 65 degrees and 9 minutes towards the, like looking out towards Y, so that would be your compass bearing. If you're not given that, you could do 245 degrees and 9 minutes, and you could take away the 180 degrees, which is the straight angle here, and that would give you this leftover angle. Alright, in the last example, we're in the northern hemisphere, or the northern half, so it'll be north, and then we're heading towards the west, so it'll be a northwest measurement, so north, heading 40 degrees 15 minutes towards the west, so that would be your compass bearing, and your true bearing would be from facing north, how far do you turn your around till you're facing out towards your Y, and that's your 319 degrees 45 minutes. The next example, just writing the true bearings for these, you can see I just wanted to point out how when you've got the angle from of A from O, so O is where you're going from, so that's where you're standing, you face north, and how far do you turn till you look out to your A. So here you've turned that 90 plus the 34, so that's how you get 124 degrees. In this one, you're facing the north and you're turning all the way around 180 degrees plus the extra 41, so you have to add it on. In the last example, it's like you've turned from facing here all the way around there, so it's like you've done the 360 but not quite made it, you've 68 degrees less, so you take that away and you've turned 192 degrees towards that point O, at point A. Sometimes you're given the actual bearing and then asked to draw the diagram. So I always actually draw the compass rose up first, just draw the cross and imagine standing in the center and which way you would be facing. So for the first one, south 70 degrees towards the east. So with your compass, like you could draw your cross here, you're facing the south, and then you've got to imagine that you've turned 70 degrees towards the east out here. So that's what your angle would look like. That would also have an angle there of 180 minus 70, 110. That would be another way of marking it on. For the second one, 48 degrees true bearing, so that would be 48 degrees from the north. So from the north, out 48 degrees from O towards A. Here, the 328 degrees, so it's, imagine you're facing north and you're going to be turning all the way around 328 degrees, so you're going to be in that fourth quadrant as you go around. So 328 degrees from O heading up towards it, because if you look at due east, that's 270 degrees as you go around, so it's further than that, it's in that last quadrant. So common examples of worded problems, so you have something like this. So ship leaves port O and sails on a bearing of 140 degrees true for 70 kilometers. So when you draw your cross, your O is at the center of the cross because that's where you're starting from, and then you can draw your bearing. Then it will work out the part of the question. So this is my diagram. I've started here. I actually should have an O written there. And you can look, I have gone 140 degrees on a bearing. So from here, I'm on that bearing. How far have I travelled? 70 kilometres. So you're writing your 70 kilometres. Because that's 140, I know that has to be 40 because that has a straight line, has to add up to 180 degrees. The question asks how far south, find how far south the ship is from where it started. So here's our starting point O, and here's the southern direction. So even though the ship's out here, we're measuring this length here to find out how further south it is. So here's my X. So I look in my right angle triangle here. This is my given angle, so I actually have the adjacent side and I have the hypotenuse side. So adjacent and hypotenuse is cos, so I'll be using cos to help me find it. So cos of 40 would equal adjacent over hypotenuse. I'll multiply the 70 across to the other side and then type that in my calculator. When you type it into your calculator, because it hasn't asked for it to a certain number of decimal places, I've rounded it to 3, but I write down what I've rounded it off to. The last example I want to look at is when we're actually finding the bearing. So this has got two towns. One town is 5 kilometres north and 3 kilometres west of the other town. So to find the bearing, we need to first draw a picture. So let's check if this picture is okay. If the town of Bartley is 5 kilometres north and 3 kilometres west of Kellyvale. So here's Kellyvale, 5 kilometres towards the north, then 3 kilometres towards the west. Find the bearing of Bartley from Kelly Valley. So basically, if we want to find this bearing, if you're here looking towards Bartley, you would need to get this angle all the way around here to say what you're looking at. So first of all, in our right angle triangle, if we find this angle, then we can do 360 minus that angle. So looking in this triangle, I've got opposite and adjacent, which reminds me that it's tan. So tan theta would equal opposite of 3 over 5. So in your calculator, you press shift tan of 3/5 or 0.6 if you want, either one, equals, and hit your degrees minutes button and you can get 31 degrees. So putting that back onto our compass rose, we can see the angle that we've just found, that 31 degrees goes in here. So the bearing is 360 all the way around. Take away that 31, leaves me with 329 degrees. So that means our bearing of Bartley from Kellyvale is 329 degrees. So remember, this has a great bearing in trigonometry. Thank you.